In this video, we're going to be looking at quadratic functions and transformation. If you find this video helpful, share, like, and subscribe. Transformation of quadratic functions. Describing transformations of quadratic functions. A quadratic function is a function that can be written in the form of f of x is equal to a x minus h squared plus k, where a is not equal to 0. The U-shaped graph of a quadratic function is called the parabola. Okay, so let's look at some key concepts of transformation here. So I'm going to show you different transformation types in here. The first one is, let's deal with the vertical translation. Vertical translations is going to be on the y-axis. Now, I wrote two vertical translations in here because in this vertical translation, one goes up and one goes down. Now, let's look at the one that goes up. G of x is equal to f of x plus k. Now, in this case, our f of x is x squared. So, that's going to be x squared plus your k. It means it's going to be going up. F has a vertical translation of k units. Okay, remember that if it is plus, it's going to go up. I would like you to look at the dotted green parabola in here. This is actually the parent function, which is going to be representing the y is equal to x squared. That's the parent function, this one. Now, if I'm going to translate that with k units, in this case, I have 3 units from 0 to here. That's actually 3 units. This is 3 units, 0, 1, 2, and 3. So my function is going to be, my new function in here now, I don't call it as f of x, or we call it g of x is equal to x squared plus 3. So it shifted up 3 units from 0. Okay, let's look at the other one. Still the same vertical translation, but this time the function goes down. Okay, you can still see plus k in here, but remember that when it goes down, the value of k will be on the negative. Okay, so for example, I'm going to say, let's say in this one, it's going to be x squared plus the value of my k is going to be negative. It's going to be, let's say, negative 2. Okay, so if you're going to simplify this further, this is going to give you x squared positive multiplied by a negative is going to give you a negative. So that means that it's going to go down by 2 units. That negative sign will tell you that it's going to have a vertical translation of k units down. So let's look at this graph. If you're going to be looking at the green dotted parabola once again, this is actually your parent function. And that parent function represents your f of x is equal to x squared. Okay. Now, the translated one is the red parabola this time. Here, you can see that it is actually translated going down by how many units? Say 1, 2, and 3. So this is going to be 3 units. This is 3 units down. It is going to be minus 3. So if I'm going to write a new function in here, this is going to be g of x. We cannot use f already because that's the parent function. That's going to give you the same shape of x squared, but it's going to be going down 3 units. It means minus 3 units. So that is the function name of it. Okay, the next one is the horizontal translation. Okay, we are still on the translations and we're not changing anything. Earlier, we had our vertical translation. This time, we're going to look at the horizontal translation. Now, I put the same horizontal translation in here because one goes left and one goes right. So let's look at this g of x is equal to f x plus h. This plus h in here is going to be written as a negative h of h, and that's going to be going on the left side of the graph. So if you're going to do this one, f of x plus minus and then minus h, okay, if you're going to simplify this further, f of x negative multiplied by a negative is going to be positive. That's the reason why it's going to go to the left side, because we are actually looking at a negative h units in here. So I would like you to once again look at your parent function in here. The parent function in here is actually the green dotted parabola. And when we shifted it, okay, if you're going to be looking at it this way, this is going to be from 0. We shifted it going to the left side of our graph. And that's actually how many units? Let's count how many is that. 0, 1, 2, 3, and 4. This is negative 4. So if we're going to be writing the function in here, the function of this is going to be g of x is equal to x minus, and then that's negative 4, so it's going to be give you minus 4, okay, and then square. Now let's simplify this one. Negative multiplied by a negative is going to be a positive, so now x plus 4 square. Okay, so this is now the function g of x is equal to x plus 4 square. It exactly looks like the parent function here. Our parent function here is f of x is equal to x square. But okay, it looks like exactly the parent function, except that it is translated 4 units on the, to the left. Okay, let's look at one more, the one that goes right. The form of that is going to be g of x is equal to f of x minus h. This means it goes right. F has a horizontal translation of plus h units. Now remember that plus h units, h is actually related to your x-axis. So let's look at this example that we have in here. So you have again the parent function in here, which is the green dotted parabola. Okay, so let's write this one as our parent function. The parent function is y is equal to x square. Okay, remember that f of x is still the same as y, the same output. Now let's look at now the transform graph, which is, we're gonna name it as g of x. So we transform it from the 0 0, and we move it to this specific point in the graph, specifically on the right side of 2 units. Okay, so let's go, we're going to write this one as x minus 2 units square. So this is now going to be the function name of this red parabola that has been transformed from the parent function y is equal to x square. Okay, let's look at vertical stretch right now and vertical shrink. Okay, vertical shrink and vertical stretch. Now I wrote something to in here like vertical stretch, and the others is actually called vertical shrink. Let's look at the differences of these two. For a vertical stretch, I would like you to look at this one. G of x is equal to a multiplied by the f of x. So in this case, remember that we are looking at our f of x as x squared multiplied by any number a. Okay, so as for example, let's give you an example in here. Let's say f of x is equal to, of course, x squared. Okay, we know that's going to be our x squared. Now our transform one is going to be g of x. Let's say it says here that if a is greater than 1, f has a vertical stretch. It means away. That's going to be going away from the x-axis by a factor of a. This is going to be the absolute value of a, and that's going to be the factor of vertical stretch. Okay, so let's give some examples. Say, for example, our g of x in here is going to be, let's say, let's give a sample vertical a. So we're going to, let's say, think of a number greater than 1. Okay, I would like greater than 1. So maybe 3 or 4. 3. Oh, 3 multiplied by x squared. This is going to give you 3x squared. So it means to say, if you're going to describe the transformation that happened here, there is a vertical stretch, okay? Vertical stretch by a factor of, okay, a factor of 3. Now let's look at the opposite of the stretch, which is the shrink. Here, it's going to be the same like the first one. G of x is equal to the value of a multiplied by the f of x. Remember, once again, our f of x here is x squared and multiplied by any number. But in this case, the value of a is between 0 and 1. It means to say it's gonna be, a is going to be less than 1. Now we can say that f has a vertical shrink by a factor of a units when it's going towards the x-axis. Okay, towards the x-axis. So if you're going to be looking at this dotted parabola, it's actually going away from this parent function and it's actually approaching your going towards x-axis. Okay, just like this one, it actually goes this way. So this is what you call a vertical shrink. Okay, so let's give you an example. Let's create our f of x. Of course, we know that is going to be x squared. Now, the transform one is going to be g of x, but I'm going to put a number before the x squared, and that's going to be the value of my a, which is a is going to be less than 1. Okay, if it is a less than 1, but not a negative number, let's say 1 over 8 x squared. Okay, so if you're going to be describing this one, it's going to have a vertical, this is a vertical shrink by a factor of 1 over 8. So this is how you describe that transformation that's happening. Okay, so let's continue. Let's look at this time the horizontal stretch and horizontal shrink. For the horizontal stretch is actually represented by b here, the b in our function. Okay, so we can say that f has a horizontal stretch. It means going away from y-axis by a factor of 1 over b units. Okay, so let's give you an example. So say for example, we are given this function g of x is equal to 1 over 4 x squared. Okay, so let's look at this one. It says that there's going to be a horizontal stretch when the value of b is between 0 or 1, or simply said, b should be less than 1 but not less than 0. So here we can say that uh, the function g of x, it has a horizontal stretch by a factor of 1 over b. Now remember this one. In this case, if you're going to be looking at this one, this is the value of our b. Okay, so if the value of b is equal to 1 over 4, then we're going to put that in our given factor or basis of doing the stretch. That's going to be 1 over b. 1 still going to be the same there, but this time the value of b is 1 over 4. And if you're going to divide this one, 1 divided by 1 over 4 is going to only give you 4. So to describe the transformation that happens here, we can say that there's going to be a horizontal stretch by a factor of 4. Okay, we get that 4 because of this basis of computing the horizontal stretch by the unit of 1 over b units. Okay, let's go to the horizontal shrink. For the horizontal shrink, the condition here is that the b should be greater than 1, and still f has a horizontal shrink. It means that's going to be towards y-axis by a factor of 1 over b units. Okay, so let's give you an example. Say for example, we are given this function g of x is equal to, let's say 4x squared. Okay, so let's see. It says that b is going to be greater than 1. Here in this case, our b is equal to 4, which is actually greater than 1. So if we're going to be looking at its factor or describe its factor, we're going to use 1 over b as our basis. 1 will still be there, and the value of b is 4, and that's going to give you a factor of 1/4. So if you're going to describe this one, it's going to say that it has a horizontal shrink, okay, horizontal shrink by a factor of 1/4. Okay, so that's how you're going to describe these transformations. Okay, last is the reflection over the x-axis. So remember that you are dealing with a quadratic function in here. So basically, we're just going to be looking at a reflection over the x-axis. Here, this is going to happen when g of x is multiplied by a negative number, or let's say that if a is less than 0, f is reflected over the x-axis. Now, if you're going to be looking at the green dotted parabola once again here, this is actually your parent function, y is equal to x squared. Now, notice that there's a positive 1 in here. Okay, there's a positive 1 here in here. Now, let's say if a is going to be less than 0. Anything that is less than 0 will be negative numbers. So say for example, y is equal to negative 1x, although we don't write it that way. We always write it without the 1 in front. Then what will happen to the graph is that it's going to reflect over the x-axis, and it's going to be looking this way. See, so this is going to be the only reflection that we can have when we come to, or when we talk about quadratic functions. Before we do our practices, I would like you to remember this one. Okay. F of x is equal to a b of x minus h squared plus k. Okay, so let's define each one of these. Our a here is going to be our vertical stretch or shrink. Okay, this is going to be our horizontal shrink, or we call it stretch also. This is going to be the h here is going to be your horizontal translation, and your k is going to be your vertical translation. So let me repeat that. VSS represents the a, which is your vertical shrink or vertical stretch. Now, the B in here represents your horizontal stretch or horizontal shrink. Okay, and then here is going to be a horizontal translation. It's either going to the left, that should be plus sign, or it's going to be to the right, which is going to just a minus sign. Our vertical translation can either be positive, then it's going to go up, and if it is negative, then it's going to be going down. Okay, so let's put into practice what we have learned today. Describe the following transformation on the function of y is equal to f of x. Okay, so let's see. What I can see in here is a reflection. Here, there's a reflection in here. There's a horizontal translation here. So let's write the transformation. First one is, it's a reflection over x-axis. Okay, why my a here is going to be less than 0. So in this case, the value of my a here is equal to negative 1. And then the other one is going to be my horizontal translation. Okay, HT, horizontal translation of 2 units. This is going to be minus, so it's going to be on the right side of the graph. Okay, let's go to the next one. Here, I can see immediately my horizontal translation and my vertical translation of negative 1. So it means it's going to go down. Okay, let's write that down. So there's going to be a horizontal translation. Okay, I will just write HT in here. Horizontal translation of 3 units to the left. Okay, so left. Okay, that's going to be minus 3. And the other one is going to be a vertical translation of 1 unit. This is going to be going down. Okay, let's go for number 3. Number 3 is y is equal to 3x squared plus 1. So I can see a vertical stretch by a factor of 3 in here. Vertical stretch by a factor of 3. And this is plus 1, so it's gonna go up. A vertical translation of 1 unit up. Okay, number 4, y is equal to negative 2x squared. Here I can see a negative. It means that the first transformation that happened is actually a reflection. There's a reflection over x-axis, and the other one is the vertical stretch. Okay, my a here is greater than 1. It means that it's going to be a vertical stretch of 2. Okay, v stretch by a factor of 2. Okay, let's go for number 5. Number 5 here is going to be again an reflection and a vertical translation. Here, reflection. So say there's going to be a reflection over x-axis, and the second one is a vertical translation of 5 units down because of the negative sign. Okay, number 6. The first thing I can see here is the vertical stretch again. My a here is greater than 1, so it's going to be a vertical stretch. V stretch by a factor of 3. Okay, so the second one is this one. That's going to be a horizontal translation of 1 unit left. And no more. That's it. Okay, number 7. So this is very nice. I can see in here a vertical. This is less this time. Our vertical factor here is actually between 0 and 1. So this is going to be a vertical shrink. Okay, V shrink. V shrink by a factor of 1 over 3. And then there's a horizontal translation of 2 units left side, and vertical translation of 3 units up. Okay, next. So I see a reflection in there because of the negative. There is a factor of 1/2 as its vertical shrink again because our a here is less than 1. So it's going to be a shrink. So let's see. The first one is the reflection. There's going to be a reflection over x-axis. And then there's going to be a vertical shrink by a factor of 1/2. Okay. And there's also a horizontal translation of 1 unit right side. And last is the vertical translation of 3 units up. Okay, number 9. Let's look at that transformation that happens here. I can only see a horizontal translation of 3 units. So there's going to be a horizontal translation of 3 units left because of the plus sign. Okay, number 10. Okay, there I saw a negative in front. It means it's a reflection. Reflection over y-axis. Sorry, x-axis. Another one is going to be a horizontal translation of 1 unit right side, right. And this is going to be a vertical translation of 4 units up. Okay, the instruction here is to write the equation for the function y is equal to x squared with the following transformation. Okay, so let's look at number 11 in here. It says that reflect across the x-axis. Okay, this one alone will tell me that it's going to be a -1. Shift down is going to be -1 also. Now, can I just use f of x as equal to x squared, which is going to be our parent function? Now, if we're going to create a new function with this transformation, we're not going to call it as f of x. Instead, we're going to use another letter, g of x. With the x squared, it says -1. -1 times x squared is going to be x squared, and then shift down 1 is going to be -1. So our final answer here is going to be g of x is equal to -x squared minus 1. Okay, the next one, vertically stretched by a factor of 3, shift right up and up 1. Okay, so our f of x again is going to be x squared. Now, my g of x in here that's being expected is going to be a factor of 3. That's going to be a factor of 3. And shift right 5. Okay, that's going to be x. Okay, it's going to be right 5. So it's going to be, if it is right side, it's going to be -5 and then square. And up 1, it means going to be +1. So this is going to be your function in there. Okay, let's go for the next one. Shift up 5. Oh, this is easy. Your f of x is going to be x squared. Your g of x in here now is going to be shift up 5. It's going to be x squared plus 5. Okay. Number 14, reflect across the x-axis, shift down 8. Okay, so our f of x is going to be x squared. So our g of x here is going to be, reflect across the x-axis, -1 times x squared is going to be -x squared. Shift down 8, it means to say -8. Okay, so this is going to be our function. Okay, reflect across the x-axis again and vertically compresses by a factor of 1/2. So our g of x in here is going to be, it says vertically compresses by a factor of 1/2. It means to say 1/2. Okay, reflect across the x-axis, so there should be a negative in front, and that's going to be x squared. Okay, no more. So let's rewrite that once again. Our g of x is going to be -1/2 x. Okay, some other books can also, you can also find it this way. It's going to be -x/2. Okay, they are actually equivalent expressions. Okay, vertically stretched by a factor of 4, shift left 3 and up 2. Okay, so let's see. Our g of x then is going to be, it says vertically stretched by 4, so that's gonna give me 4, and then shift left by 3, it's going to be x. If it is left, it's going to be +3, and then square up 2, so +2. So this is your function. Okay, number 21, if you wanted to shift y is equal to -3 times x minus 2 squared plus 1 down 4 units and left 5, what would be the new equation? Okay, so I noticed that it is down 4 and left 5. Down 4, it's a vertical translation of -4, and left 5 is going to be a horizontal translation of +5. Okay, so our f of x in here is going to be negative 3 times x minus 2 square plus 1. Now, our g of x in here this time is going to be different. Okay, so I say g of x now is going to be negative 3 x minus 2, and then I'm going to add this part, plus 5 square plus 1, and then this one again minus 4. So here it's still going to be the same, negative 3 x minus 2 plus 5 is going to give you plus 3 square, and then 1 minus 4 is going to give you minus 3. So this is going to be your new function in here. If you wanted to shift y is equal to x plus 3, left 2, and up 5, what would be the new equation? Okay, so our f of x in here, which is the original, is going to give you x squared plus 3. But they are asking us that says left 2 and up 5. Left 2 represents your horizontal translation of plus 2, and up 5 is going to be your vertical translation of plus 5. Okay, so we're going to create a new function again in here, and we call it g of x. It's going to be uh, x plus 2 square plus 3 plus 5. Okay, so my final g of x in here is going to be x plus 2 square plus 8. If you wanted to shift y is equal to x plus 4 squared down 3 and right 2, what would be the new equation? Okay, so our f of x in here is equal to x plus 4 square. And it says down 3, it means to say that's my vertical translation of minus 3, and right, that's going to be a horizontal translation of minus 2. So if we're going to create our g of x in here, it's gonna be g of x is equal to x plus 4 minus 2 square minus 3. Okay, so our final answer here is going to be, let's simplify these two parts. X 4 minus 2 is 2 square minus 3. This is your final answer. Number 24, if you wanted to shift y is equal to negative x squared, right 3 and up 5, what would be the new equation? Now, I would like you to notice something in here, that the f of x is actually reflected negative x squared. It means to say that our a in here is equal to negative 1. So if you're going to look at or remind yourself about the vertex form of our quadratic equation in here, or function rather, a is going to be x minus h squared plus k. So our a in here is negative 1, that one. Okay, so let's now create our g of x. Our g of x is going to be, it says here, right 3 and up 5. Right 3 is going to be my horizontal translation of 3, and then it's going to be a vertical translation of plus 5. Okay, so let's see, that's going to give you negative x minus 3 square and then plus 5. Okay, so this is going to be your function. So this is all for the quadratic functions and transformation. If you find this video helpful, share, like, and subscribe. Thank you very much.